Hey, you lemons, thanks very much for coming, guys. Hey, Laura, thanks for commenting on the chat. Right, I'm going to crack straight on with today's lesson. Let's share screen. Today's lesson is on Alkenes lesson 2. This is addition polymerization. So we're talking about polymers today. Okay, so learning objectives, switching to tablet mode. It's like a transformer. So we've got, the title is addition polymerization. 4 learning objectives, no alkene terms. So I'm just going to be giving you lots of words today, and I'm sorry that you have to just learn them, guys. It's just a pain, I know. But know your alkene terms. Number 2 is understand the process of addition polymerization. Number 3 is be able to draw monomers and polymers, which, by the way, can be a lot of fun. I'm going to show you all the polymers that you guys all know today. So, you know, I'm going to show you polyethylene for your plastic bags. I'm going to show you polystyrene. I'm going to show you polyvinyl alcohol, otherwise known as PVA glue. I can do all the plastics. I can show you acrylic. I'll show you all the polymers that you guys will know and recognize from being in the house. So, and then the last one is be able to name your polymers. Okay, so let's do some terms. So the first thing we need to do is we just need to do alkene terms. So these are just the words that they're going to ask you in your exam, alkene terms. So number 1, or even underline it if we wish. Number 1 is they're going to say it is unsaturated. So the word unsaturated has a definition. I'll do the definition in blue. So the definition for unsaturated, a compound containing a carbon-carbon double bond. It's a rather odd thing that you're saying carbon-carbon double bond, carbon-carbon constitution, you have to say carbon-carbon double bond. So the term unsaturated, can anyone guess? Now, this is one of the ones which I hate this one. The word saturated. So if the word unsaturated means I have a carbon-carbon double bond, guess what the word saturated means? Isn't it ridiculous? It's a definition that you say is a not definition. It's just saying, I don't have this. Isn't that stupid? You are not allowed to say contains carbon-carbon single bonds. You're not allowed to say it. You have to say that it doesn't contain them. Now, students often ask me why that is. The reason being is, well, we can now say, so I can now ask, Atia, can you name this little baby? Well done. I love how instantaneous, there was no doubt in your mind, and you did it. It was just, that's exactly what that's what I would expect it to be. It's just ethene. And we can call that unsaturated because it contains the carbon-carbon double bond. But, well, what about this guy? So I'm going to now ask, Amani, can you name this guy for me? All H's. I love the number. Propanene, there's propene. Yeah. And we can also call this unsaturated, but you realize why the definition for saturated is what it is, because it also has a carbon-carbon single. That's the problem. So we can add that to our notes. So the term saturated, number 2. So the term saturated, and I hate it. I really hate it. I'm pretty sure in my GCSE, the reason why I hate it so much is because I got it wrong. Pretty sure that's right. Yeah, you have to say doesn't. Go on, Libby. It's unsaturated. Yeah, funnily enough. The word unsaturated kind of means that you can add to them. Yeah, and you can add to a triple bond. A triple bond would also be classed as unsaturated. Yes. I know, but it's interesting that like there was a definite problem with the definition. Yeah. Doesn't, so stupid, doesn't contain a CC. I'm just going to do that. Is everyone okay with that? Yeah, go on, Marnie. Oh, they'd probably allow it at GCSE. I'd advise you not to. It'll probably be in the except column, but it's really easy to miss the word only. That's the only reason why I'd stay clear of it. But yes, I think they'd allow it. Yeah, I think they would. Okay, next one. I think everyone here knows this one. Hydrocarbon. Everyone knows this. Hydrocarbon. Hydrocarbon. And I'm going to go for Kayla. What's the definition of a hydrocarbon? Well done. Outstanding, young lady. Great job. Compound made from. Can I just point out, you just gave a flawless definition there. Everything was exactly the way that I would want that. Well done. Really appreciate that. It means you've done some great learning. Compound made of carbon and hydrogen only. And you have to say that word only. So just really quickly, just to give you an exam question of this one. So I'm now going to draw you another molecule. Oh, yeah. Let's go for this guy. I'm going to ask Tiff to name this for me, please. Yeah. Impressive. Say it. Well done. That's ethanol. Isn't that cool? We can start picking up multiple families. We had ethene, propene, and now ethanol. That OH gives it the next functional group, the next part of the molecule that implies the function. And yes, if you drink ethanol, you will get drunk. You will also die, but you will be... I realize I'm live on YouTube. I'm going to walk away. So we've got ethanol. Love it. So my next question, of course, is, Lynn, is that a hydrocarbon? No, it's not. As soon as you see that oxygen, we realize no longer a hydrocarbon. Right, next word, monomer. Number 4. Monomer. Okay, so now, as a teacher of chemistry, I love that the chemists have been clever about their naming. 95% of the time, they've been really clever. Like, I get it. That's actually why I loved chemistry, because the process made sense to me. You know, biologists, completely the opposite. They just make everything up. Yeah, it's a nightmare. It's not even a real science. So the problem is here is when you do the understanding, you say mono means one, mer means part, but that's not the definition, which is a bit of a problem. So we need to say a monomer, a single unit that, I suddenly realized I'd like it to be in red or blue, I don't mind. A single unit, brackets, I'm actually going to put this in a context. I'm going to say alkene, yeah? A single unit alkene that can join together to form a polymer. It's a bit of a nightmare definition. You've got to go beyond just this one part. One part would never be enough. You're saying this is one part that can be used to make a bigger, many parts. Does that make sense? Yeah? Can I just point out, by the way, the addition of the alkene in the bracket, yeah, this actually is not entirely necessary. The reason being is there are other types of polymers, and you can have monomers that aren't alkenes. That is a thing. But it's nice to have this in the context of your alkenes because this is where you're going to see it. So it's worthwhile including it. The next word, of course, is polymer. So what is the definition of this word polymer? It means many parts. So how do we now explain this? So if that's a single unit, a small single unit, a polymer is a giant molecule. So I'm going to do this in red, a giant molecule. And what's it been made from? A giant molecule made from many repeating units. And at that point, you say units, brackets, monomers. So isn't this weird? In the definition of the word monomer, you must use the word polymer. So by the way, let me explain to you why. Because would you everyone agree that Amani in the class is a single unit? She is indeed a single unit. Could we string many Amanis together? No, you can't. She is a single unit, but we cannot create a larger structure for many Amanis, which means even though she would be classed as a single unit, she is not a monomer because we cannot join them together to make a polyamani. God, can you imagine how much of a nightmare that would be? Polyamine. Wow, it's amazing. Anyway, and then the word polymer has the word monomer in it, saying that it's a giant structure made from many repeating units, monomers. We're done. Cool. So we picked up a whole load of these terms for alkenes. Ugh. One more, last one, number 6, addition. Addition, polymerization. Now, okay, and this is a reaction. Yeah, this now is a reaction. And I'm going to actually split this up because this now, these are all worth 1 mark, by the way, most of the time. These 5 definitions tend to be worth just 1 mark at Excel. Yeah, at AQA tend to do a couple of them at 2, but at Excel just does them as 1. But this one now is different. Addition, polymerization. A reaction where monomers join together to form a giant polymer. Now at that point, there's your first mark. There's your first one. Now that makes total sense, right? They're adding together. Yeah, these monomers joining together to form this giant polymer. The next bit is you need to actually give a little bit of detail. You need to explain to them, how is that happening? Yeah, so to form a giant polymer, the double bond, so, oh my God, yeah, get me some chicken nuggets. Oh my God, yeah. Oh my God, did you say 9? Give me 9. Give me 9. Oh my God, you are now officially my favorite students in the school. That's all that matters. That's it. Stop. Say again? Get me a Big Mac meal. Just give me a medium. Amazing. You guys are legends. Thanks. That's boss. Now officially, they've all just got more marks on their marks. Amazing. Instantaneously. I'm still live on YouTube, aren't I said nothing of anything that's going on here. Anyone like part of this? There you go. Oh no!
I've had a lot in the past.
It doesn't say COVID on the.
Too many.
You've had so many pineapple biscuits over Chinese New Year, you're done.
Yeah.
I totally get it. Totally understand this. You're very welcome. Sorry about those people on YouTube, by the way. Apologies. You don't get any biscuits, I'm afraid. They're really nice, these ones, actually. Of all the ones I've had so far, these have been the ones that I preferred. I'm not a big fan of the ones that, like, a biscuit with, like, the gelatin on top.
Oh, yeah.
I'm not a big fan of those. So, sorry, anyway, back to the lesson. Anyway, so the reaction where monomers join together to form a giant polymer, the double bond, back to the lesson, the double bond in the alkene breaks open, and they link together. You're done. So it's just a description of the process that's being involved here. Yeah, you say that the monomers join together to form a polymer, 1 mark, the double bond breaks open, and they then allow them to link together. You're telling them that without that double bond breaking open, that it doesn't happen. That's what you're doing in the description of this reaction. Yeah, we can also, of course, draw pictures for all this, which is now coming. So we're end of our terms. Tick, 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 tick. Amazing. Right. Now we get, I love the fact that my last definition was addition polymerization, and now we can draw a picture of it. Right. So let's keep this super easy. Let's start off simple. Yeah. So we can do, there we go. I'm going to do this one. Right, I'm going to ask, who have I not asked? Caitlin, can you name that, please? You can pass if you like. Well done. That's 1-chloroethene. Well done. Great job. Just to tell you, by the way, you don't need the number 1, but it's better that you put it in. I'm glad you did. I teach my A-level students, you always include the numbers because you can never go wrong with the numbers. They never remember how to, when not to and when to, so it's a nightmare. Just always do it. So we've got 1-chloroethene. Let's draw another one. Yeah, let's draw another one. I shouldn't be drawing them slanty like this. This is not a good way of doing it, Mr. Duncan. Come on. So here's the next one. Here's another 1-chloroethene. Let's take another one. Let's do another one. Yeah, hello. 3 of them. Yeah. There we go. So many 1-chloroethanes. Now what we're going to do is we're going to join the guys. Can you please break the double bonds and link them all together? Off you go. That's your challenge. Go. So I've given you 3. Put them all together, please. Literally do the definition of what I just said right there. Yeah, there we go. Take that image and draw for me what this is now going to look like. Yeah, it's a clever process, this, and it's worthwhile doing this kind of exercise because it helps build the understanding of what's happening. So all you're going to do here is snap the double bonds open, link them together. Yeah? Doing great, yeah. Doing great.
Oh, wait, sorry, I forgot for it.
But not just that, there's another thing that's very important you've got on. Yes, they do. Look at you're not looking at the image I've given you and what that will look like if you link them together. Because they're going to be in very clear places, aren't they? Just one thing on this one. Yeah, well done. You start really close.
Oh.
Great job. Oh, yeah, look, come on. They're just open. Because in reality, more going on here. The fact that we've got 3, but people often just say hiding from me. Super common. And it's definitely not what happens. So it's really nice that. It was great. Well done, Harney. So let's have a look at what this becomes. So guys, what I'm now doing is I'm teaching you a routine here. Can you see, by the way, that often alkenes are often drawn in what is often commonly called a spider diagram. Yeah, I'm going to give you this one. This is called a spider diagram. They wouldn't call it that, by the way. It's just commonly referred to. What I mean is like these 4 legs sticking out in these angular positions. I'm going to ask Helping to name that, please. Impress me. So close. Give me the number. Butene. Well done. That there is 2,3-dimethyl-butene. Yeah? Not complicated. It just takes practice. Yeah, can I just have a quick show of hands if you could have done that? Well done. Don't worry if you can't. As I said, that's AS naming. Don't worry. Yeah, you will not have that. But what I'm trying to do here, guys, that image there, in order to do the polymer, needs a little bit of tinkering with. What I'm going to do is I'm going to what I like to describe as straightening it out. What I'm going to do is this. I draw the double bond like that. So this carbon here and this carbon here. Yeah, they are the same carbons. Now what I do is let's focus on the pink one. So the pink one, I've got a CH3 and a CH3. So I'm going to put them straight up. Can I please point out, look at where my bond is going. Who's it going to? The carbon. Do not do this. This is not good chemistry. Yeah, and definitely don't do that. Yeah, that is not good. Hydrogen will not do that. It's going to go to the C. All I'm doing is so I've done the 2 pink ones. I'm just attaching what it is. Now I focus on my yellows. I've got the same group again. I'm just going to point them straight up. All I'm doing is I'm straightening it out. Now there's a reason for this. Let's go back to my image before. And you guys did this automatically. What I will do is I'll just straighten them all out. Yeah? H, 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 Cl. Straighten it out. Yeah? H, H, HCl. Straighten it out. HCl. Right. And this is the important bit. 2 long bonds coming off the end. There are not hydrogens on the end of them. There were no hydrogens to go there. These are just saying, I'm ready for more. Yeah, we know that I've given, this exam question is, draw the polymer with 3 repeating units. It's nice to look at this as an exam question, and I'll show you all the different types in this lesson. By the way, notice where the chlorines are. The chlorines are every other. There's a repeating pattern. Does that make sense? You can't just do this. You can't just whack all the chlorines over here. That's not a thing. Yeah, you're moving stuff around. Can't do that. They're going to be going on in a repeating fashion. Okay? Are you ready for your next one? By the way, just to tell you, this polymer that you have just drawn, this is PVC. You guys all know this plastic? All the pipes in your buildings are made out of it? Yeah, there were certain pieces of clothing that are also made out of PVC plastic. Shoes. Yeah, that's one. Oh, yeah. So PVC. Next, let's go for the next one. So here's the next one. So you've seen PVC. Let's do polypropylene. By the way, all of your drinks bottles, the lids, the harder plastic at the top, that is all polypropylene. So let's do that one. So guys, what I'm going to do is I'm going to give you propene. There we go. So I'm going to give you an exam question. So the question here, and I'll write exam, it will say, draw the polymer created, don't know why I did a capital, didn't mean to, created by propene showing 2 repeating units. 2 repeating units. Perfect. They've given you propene, so then they say, and they give you a box. Draw your answer. Off you go. Have a go at that one. I'm going to come around. If anyone needs any help, I'm here to help. So the exam question, draw the polymer showing 2 repeating units. Step number 1, straighten it out. Step number 2, break the double. Step number 3, link them together and stick out the arms. That's it. It's a 3-step process. Straighten out the picture. Yeah, break the double, link them together. I'll give you a minute to have a go. Come on, if you already finished. Well done. Man, you get this, don't you? Easy. Fab. Well done. Super. Well done. Perfect. Exactly what I'd like to say. Exactly. You lost something. Because straightening out things, it's a trick, isn't it? Because what you're really doing is you're not straightening out as a line. You're straightening out these triangular lines here. You just put them up and down vertically. So you can see what the double bond is. So how I put the H now straight down, and then the CH3 straight up. You sure you can do this if you like? Don't mind. Yeah, can do. And now what goes onto this card? A H and another H. Like break the double. So just you just sort of raise one, stick the lines out, and then you do the same thing next to it. So you get 2 repeating lines. Does that make sense? It's just a repeating section. How about the whole things? He's showing me he's got it absolutely spot on. How about the whole things? Right, let's draw it out. So we need 2 repeating units. I'm going to draw 2 monomers in my box. I'm going to straighten them out. What does it look like up here? Straighten that out. Remember, the bond is to the C, not the H. I'm going to draw that again. Draw it right next door to it. Yeah? Just go vertically, break the double, and link together. And then out and out and done. Put your hands up if you got it. Thank you. Good job, guys. Right. So this is polymerization. poly in brackets what it's made from. So we're beginning the process of how to name a polymer. To name a polymer, because the chains are so long, there's no sensible way of naming it. So what you say is many alkene. Whatever alkene you use to make it is what. So helping, can you give me the proper name, please? The IUPAC name for PVC. Well done is correct. So this was made from chloroethene. So the proper name for PVC, this, by the way, PVC is the old name. Yeah, it stands for polyvinyl chloride. Go figure. Vinyl means two in the old speak. Yeah, if you ever go and work in the chemistry industry, by the way, the old people really don't like it if you don't know the old names. They will refuse to use IUPAC because they're like, we learned the old names, you will learn the old names. So if you go and go, this is polychloroethane, they'll slap you. So this is actually, no, shouldn't put that in a bracket there. So this is poly in a bracket chloroethene. That is the actual name for PVC. Yeah. If you're interested, I can give you this one here. This is polyvinyl. Go figure. Chloride. Go figure. Go figure. Next. Okay, so we've had one exam question on a repeating unit. Let's go for the next one. So we have seen so far polyethene, polypropene, and polychloroethene. We've seen three plastics that you guys all know about and use every day. Should we go for the next one? So those people who take art, do you know you guys that like every time I go into art, basically I just seem to walk in and the kids have just got glue sticks and they're rubbing them on the back of their hand. Yeah, I don't know why you do this. Yeah, you put all the glue on the back of your hand and then you peel it off. I'm completely baffled as to the interest in this particular activity. I'm not entirely sure. I'm waiting for the day that I see someone go and just stick themselves at, either that or it's like, Achoo! Oh, like I'm waiting for the day that happens, but still, anyway. So, by the way, the glue you're using is PVA, polyvinyl alcohol. Guys, what did vinyl mean in the old days? It means two. So, I'm now going to ask Dominic, can you please name me this guy? That was weird. Say again? Don't overthink it. Nice and easy. How many carbons? Eth, een or ein? Een or ein? Een or ein? Een. Family, please. Oh, ethanol. Yeah, this is the thing. There's no reason why you can't get it. By the way, we know that the OH group is the alcohol group. You can drink ethanol. It will get you drunk. It will also kill you. Don't do it. Yeah. It's still live on YouTube. You really need to start realizing what I'm saying on YouTube. Ethanol. Right, guys. Now, notice the difference in the exam question. Exam. It will say, draw the polymer. Draw the polymer made from ethanol. Right. Now notice they have said nothing about the number of repeating units. They have simply said, draw the polymer. So, what do we do? Number one, I've straightened it out for you already. So we're already on the second step. Break the double bond. And you extend it out. Put it in a bracket and put N. So this is what they're saying is they haven't told you the number of units. What that means is you need to show it can be any number of units. Any number of repeating. So this means Any number of ethenols, all joined together. Question? Is there any reason why ethanol is drawn like that? No, it would be spider one. Yeah, spider one. I just did it like that. By the way, to tell you, ethanol is a really polyvinyl alcohol. It's a really interesting polymer because it's water soluble. You can put this polymer into water and it will dissolve. The reason being is it can form the same intermolecular bonds between the water molecules. It's still called hydrogen bonding. And so anyway, it becomes, this is why, you know when you blow on your wrist and it dries, what you're doing is the blowing is evaporating the water leaves and all the chains come back together again. Does that make sense? It's kind of cool that. There are actually many different types of glues. Yeah? All glues are polymers. All of them. But they are very different in the way that they work. Some polymers do an evaporation process, such as PVA glue. Yeah? Some polymers use a mechanism where they actually link together to form covalent bonds. Has anyone ever here used epoxy resin, where you have to mix two glues together? That's not two glues. That is one glue and a catalyst. And the catalyst causes the chains to actually physically bond together, and then it becomes really, really hard. Yeah? Anyway, so there's PVA. Isn't it cool seeing all the glues that you guys know? I think it's cool, all the polymers. PVA, polyvinyl alcohol. PVA glue. Next, okay, let's go for the next one. Let's go for acrylic. So acrylic, by the way, which is this stuff. This is acrylic. I don't know if you guys know acrylic. It's all the stuff that they tend to put stuff inside of. Really hard plastic. Acrylic. That's how you spell acrylic. Acrylic. And acrylic uses this monomer. It uses this guy. There you go. Okay, helping impress me. It is an AS family that I have taught you. Well done. I'm very impressed, young man. Very, very impressed. Prop 2-ene 1-nitrile. You don't need the 1 in reality. You don't actually need the 2 either, but it's better to use it. Prop 2-ene 1-nitrile. So, by the way, this little group up here, the CN, is a nitrile family, part of the AS, one of the 10 AS families. Okay, guys, so show me acrylic with 3 repeating units. Off you go. Show me acrylic with 3 repeating units. I'll write down the question. It's good to do it. Yeah, so exam question. Yeah, draw the polymer, showing 3 repeating units. Nice. Don't overthink it. Repeating units. Love it. Acrylic. Step number 1. Straighten them up. Just put them up. Put the legs up and down. Draw 3 of them. Break the double. String them together and stick the arms out. You're done. Oh, do you know what we're going to do now? I'm going to give you a polymer and make you draw me the monomer. Oh! Boom. Drop the mic. What? Oh, no, I need to stop. I'm still on YouTube. Right. You guys, so here's the answer. I'm just going to string 3 together. Oh, if I string 3 together, how many is going to be in my line? If I string these 3, how many do I need to now put in this line? It's clever, this, isn't it? What you start to realize is with any alkene, it doesn't make any difference about what the other bits are. The only thing that really matters is the C double bond C. So I'm going to need 6 of them and string it out. Right, now I go repeat unit 1, repeat unit 2. So I'm going to go, that had a H and a H and a CN at the top and a H. And this one had a H and a H and a CN and a H and a H and a H and a CN and a H. There we go. Get rid of those. Boom. There we go. Acrylic. Isn't that polypropene nitrile? Commonly known. I like it. Okay. Next one. Yes. Good question, Zach. It's a triple bond to the nitrogen. Yeah, nitrogen forms 3 bonds. Carbon makes 4, so it does that. Yeah. Don't worry about it. You don't need it yet. Need it next year, but not now. Okay, guys. So we've now seen acrylic. Okay, this time I'm going to flip the question. I'm going to draw you a beautiful polymer, and I'm going to ask you to give me the monomer. So this one is polystyrene. You guys all know, you know it well. You know it well. You know it well, Horatio. Sure, that's from a... I'll stop. Look at that bad boy. Woo-hoo. Here is polystyrene. You see it all the time, all the packaging. Terrible for the environment. Amazing. There you go. Draw me the monomer. Polystyrene. Draw the monomer. The monomer. The monomer. Draw the monomer. And I'll give you a little box to put it in. There you go. Draw me my monomer. What was that made from? Oh my God. How hang? Could you name that? Could you name the monomer? It's got a benzene in it. Do you know the benzene name of it? Don't worry if you don't. It's A2. A2 is still right. It is finished on phenol. Yeah, so this is going to be phenolethene. Yeah. This is easy. This is maybe malicious on this one. It's easy as not. Right, so just to say, by the way, so I never used to teach polystyrene at GCSE. I only ever did it at A-level until they put polystyrene in the GCSE exam. Yeah, and they gave me this exact question. They gave me the polymer, just said, draw the monomer. Can I also point out that that funky little hexagon, you did actually need to draw it well. Yeah, it was amazing how many students took this picture here. They went, right, where's the repeating unit? There. It's repeating, there's 3 of them there. So I'm going to put the double bond back. Yeah, for the middle one. Yeah, and it's amazing how many people, I have people doing this. Yeah, that is not okay. Yeah. Can I also say this is also not okay? That is not okay either. Yeah, notice that you needed to copy the picture exactly. And it is joining at a peak. Yeah, that's because this is a ring system of carbons and you're linking to one of the carbons in the ring. There you go. And this here is called phenylethene. So the proper name of polystyrene is polyphenylethene, commonly known as styrene, because it was easier. People didn't like phenylethene. Don't know. It's too long. Just call it styrene. Cool. So we can now do, let's go back to my learning objectives. So we understand the process of addition polymerization. We can draw monomers and polymers, and we've also been doing naming as well, which has been super cool. Is there any others that I want to do with you that you might? I'm tempted to show you one that would. It's just a bit ridiculous, but I don't think there's any point. God, guys, this lesson finished absolutely on the dot, 12 o'clock. I will end my lesson there. It has been an absolute pleasure, guys. I hope you found it useful. Oh, hi, Ananya. Oh, Ananya, I'll send you an email today. I hope you have a nice rest of your day, folks. Take care. Bye, everybody.